Hey guys, good to see you again. This is the end of today's notes over trigonometry. We threw some things into the notes this time that weren't in the original video. So this is kind of an amendment. I'm going to work through the end of this plus a few questions off the homework that weren't in the original video. First, the original video did not get into inverse trig. We're going to talk about that right now. For this particular question, I want to know what is the sine of theta, the cosine of theta, the tangent of theta, and then I ask you what is theta. So that is 4 different questions that have 4 different answers. First things first, if you have a right triangle and you know 2 of the sides, guess what? You can do Pythagorean theorem to get the 3rd side. So we have our calculators now. You could just type this in, or if you recognize the pattern, that would be even better. Isn't 14 to 28 a ratio of 1 to 2? Therefore, we would know that this side is 14 root 3. You can do Pythagorean theorem on that if you want to confirm it, but I promise you that this has to be 14 root 3. We know that pattern. So sine of theta, if you remember, and I've told you guys, write this on your page every time if you need to, but sine is the so part of so, ka, toa. So we're doing the so part. So sine of theta has to equal the opposite over the hypotenuse, which on this question, if this is my theta, opposite hypotenuse would be 14 over 28. But you have to fully reduce that. The final answer would be 1/2. Sine of theta is equal to 1/2. Cosine of theta, that's the ka part. That is adjacent over hypotenuse. So if we go to theta, the adjacent side would be 14 root 3. And the hypotenuse would be 28. Well, that reduces to root 3 over 2. So that would be the cosine of theta, root 3 over 2. And then the tangent of theta is the opposite side divided by the adjacent leg. And opposite of theta would be 14. And the adjacent leg would be 14 root 3. Well, reduce first. The 14s cancel out. That is 1 divided by root 3. We can't leave it like that. So we multiply the root 3 to the top, and we get root 3 over 3. So that would be the tangent of theta. Now, the next thing I'm asking for is how big is theta? Inverse trig. Guys, inverses are undoing. How do you undo an operation? For instance, if I said 7 times x equals 10, how do you undo times 7? You divide by 7 to cancel it out. That's the inverse of times 7. If I said x plus 7 equals 10, how do you undo plus 7? Well, you subtract 7 from both sides. That's the inverse of plus 7. What is the inverse of sine, cosine, and tangent? Well, it's a little bit funky how it's written, but the inverse of sine is written like this with a little -1, and that's one of my least favorite things in math, the way we write it, because a lot of people might think that's the exponent -1. But in this context, it's telling you to do the inverse of the sine function. I don't know, excuse me, I don't even know how they do it. So talking about previous questions, like when this was 12 degrees, when we did tan of 12 over here, I don't know how they take tan of 12 and get that decimal number. I don't know. It doesn't really matter. But you also have to undo that process. Well, the calculator knows how to do that. So let me just kind of show you on the calculator here. How are we going to undo the sine function? Well, your calculator has a key here. It's called sine, right? Boop. Look right above it. Inverse sine, inverse cosine, inverse tangent. If I do shift sine, that's how we're going to do an inverse sine in our calculator. Okay, so what would we do on the first one? If the sine of theta on the first one equals 1/2, isn't that what we said? We're going to undo the sine. We're going to do inverse sine of sine theta. Well, if I do inverse sine of one side, I have to do inverse sine of both sides. And what happens is the sine and inverse sine cancel each other out, so we're left with theta. And then we have the inverse sine of 1/2. This is what you would type into your calculator. Now, my hope is that maybe you recognize that, but that can be kind of hard to do, but 1/2 is one of our very special ones. It's going to come out to exactly 30. Yes, this is a 30, 60, 90 triangle. Here's the cool thing. It doesn't actually matter which one you do. So the second one, cosine, if you set this one up, this one would be the inverse cosine of root 3 over 2. That will also be 30 because it's still representing the same angle, right? Weren't there 3 ratios that all use theta? Tan, sine, and cosine. If I do inverse tangent of root 3 over 3, I will also get 30. It doesn't matter which one you type in, you're going to get 30 all 3 times. Okay, so let's do another one. We're not going to do all of that work this time, but we're going to set this up. Here's our angle. We have to figure out how the 6 and the 7 relate to our angle. This side is opposite, this side is adjacent. So that is the TOA part of SOHCAHTOA. So the tangent of theta equals opposite over adjacent. For this question, the tangent of theta is going to equal 6 over 7. I'm going to scoot that over a little bit because what I'm about to do is take the inverse tangent of both sides. Well, the inverse tangent and the tangent cancel out. And over here we get inverse tangent 6 over 7. So we're left with theta equals the inverse tangent of 6 over 7. We type that in. Inverse tangent of 6 over 7. And that is 40.601. Default rounding is to the nearest thousandths unless you're told otherwise. Perfect. All right, and here's some mixed practice of everything we've done today. I'm going to go pretty fast through this, but this is a little bit of everything right here. We figure out the angle and how the other sides relate. This is the SO part of SOHCAHTOA. So the sine of theta equals opposite over hypotenuse. The sine of 40 is going to equal 10 over x. If x is down low, they switch places, you know. And this one says to round to the nearest thousandths. So 10 over the sine of 40 would be 15.557. The thousandths is 3 digits. 0.557. Next one, nearest whole number. This is opposite and adjacent for my angle. So that is the TOA part of SOHCAHTOA. So tangent of theta equals opposite over adjacent. So the tangent of theta equals 10 over 24. How do we undo tangent? We do inverse tangent of both sides, and this is what it looks like. So I'm going to type in inverse tangent of 10 over 24. And it says round to the nearest whole number. That is going to be 23 degrees. Oh, wait. Oh! That's a weird, I didn't ask for cosine theta. Sorry, I meant to ask for just theta there. Not cosine theta, just theta. And theta would be 23 degrees. All right, on the next one, we have this angle. This would be opposite hypotenuse. That's the SO part of SOHCAHTOA. So the sine of theta equals 12 over 50. So inverse sine, so theta would equal the inverse sine of 12 over 50. That's how we undo sine. And then we're going to round to the nearest hundredth. So I'm going to type in the inverse sine of 12 over 50. And I get 13.89 when I round to the nearest hundredth. All right, next one, nearest thousandths. Here's my angle. This would be opposite and adjacent. That's the TOA part of SOHCAHTOA. That's the tangent of theta equals opposite over adjacent. This time theta is 11 degrees. Opposite is x and adjacent is 14. If x is up high, all you got to do is multiply. So x would equal 14 times the tangent of 11. 14 tangent 11. Round to the nearest thousandths would be 2.721. And then one more, two triangles to work on. The first one's a 30, 60, 90, so I don't need my calculator. The side across from 60 is 15. So remember that the long leg equals the short leg times root 3. So if we take the long leg, that's 15, And that equals the short leg root 3, divide root 3. Hopefully you can do all this in your head. That's the hope. This is the stuff we just took a quiz on. 15 divided by root 3, the short leg would be 5 root 3. So this side is 5 root 3, making this hypotenuse 10 root 3. But remember that the hypotenuse equals the short leg times 2. All right, so now we have the hypotenuse of the next triangle. So we're going to work on this triangle, and that's a 35-degree angle. So that one will require the new rules, the new trig. This is the adjacent leg. This is the hypotenuse. That's the ca part. Ca. So that is the cosine of theta equals adjacent over hypotenuse. So this would be the cosine of 35 equals adjacent x over hypotenuse 10 root 3. If x is up high, all you got to do is multiply. So 10 root 3 times the cosine of 35. And it didn't give us thousandths. So I'm going to type this in and round to the nearest thousandths. 10 root 3 times the cosine of 35. Nearest thousandths will be 14.188. Perfect. All right, I'm going to move on to the end of the homework. So I added a few questions that are not in the original work-through video. And so we're going to do those right now. Which questions did I add? I think starting here. So let's work through some of the last homework questions. And I'm going to go real fast through these. All right, round to the nearest whole number. This is my angle. This is opposite adjacent. That's the TOA part of SOHCAHTOA. So the tangent of theta equals opposite over adjacent. Since the angle is missing, this will be the inverse tangent of the ratio. We take the inverse tangent of both sides. We type that in, inverse tangent of 10 over 12. It says round to the nearest whole number. 39.8 would round to 40 degrees. That is a 40-degree angle. The next question, we have our 17. We need x and y. This is the adjacent leg, the opposite side, and the hypotenuse. So solving for x first, we would do adjacent. That's the cosine. That's the ca part of SOHCAHTOA. So the cosine of theta equals adjacent over hypotenuse. So this would be the cosine of 17 equals x over 11. If x is up high, all you got to do is multiply. Get it right your first try. Getting tricky with it. So type that in. 11 times the cosine of 17. Round to the nearest thousandths this time would be 10.519. And then we'll do the y value. Y is opposite over hypotenuse. So that would be the SO part of SOHCAHTOA. That would be the sine of theta equals opposite over hypotenuse. So the sine of 17 equals y over 11. If y is up high, all you got to do is multiply. Get it right your first try. So that's 11 times the sine of 17, and that's 3.216. There are your answers. Nice. And then I think we got two more. Nice. Next question, we have our 37. This would be opposite, adjacent, hypotenuse. I am going to work on x first. X would work with opposite over adjacent. That's the TOA part of SOHCAHTOA. So the tangent of theta equals opposite over adjacent. So this one's 37 degrees equals opposite x over adjacent 15. So x, if x is up high, all you got to do is multiply. So it'd be 15 times the tangent of 37. And that rounds to the nearest thousandths again, be 11.303. And then finally, we'll solve for the y value. That is the hypotenuse. So that one is so to solve for y, that's the cosine ratio. The cosine of theta is adjacent over hypotenuse. So the cosine of 37 equals adjacent 15 over hypotenuse y. Well, if y is down low, y in the trig switch places, you know. So that would be 15 over the cosine of 37. So we type that in, 15 over the cosine of 37. Round to the nearest thousandths again, that would be 18.782. Got it. All right, one more question here. What is the sine of theta? So sine of theta, it did not say how big is theta. Theta equals and sine theta equals are two totally different things. This is asking for how big is the angle. I did not say to solve for the angle. I just said what's the sine of theta. All right, well, sine is the so part of SOHCAHTOA. We know that sine theta equals opposite over hypotenuse. I need the hypotenuse. So I would need to reduce these numbers. Divide by 2, this would be 7. Divide by 2 would be 24. Ooh, that's a 7, 24, 25. So this side would be 50. So the sine of theta is going to equal opposite 14 over hypotenuse 50. So the sine of theta, reduce that, would be 7 over 25. Your answer must be fully reduced. If it's not, you're wrong. So don't give me a different ratio. Don't give me an unreduced ratio. Don't give me theta. I did not say solve for theta. If I asked you to solve for theta, you would do the inverse sine of 7 over 25. That is not what I asked you. So we got to be real careful there. All right, guys. I think that's it. Love it. I'll see you later.